Good morning. This is Ms. Billerbeck, and we are going to talk about 9.5, completing the square. So the process of adding b over 2 squared to x squared plus bx to form a perfect square trinomial of x squared plus bx plus b over 2 squared is called completing the square. Well, this is kind of difficult to understand. So let's just use the manipulative so you can see what x squared plus bx plus b over 2 squared looks like. So if we have an x squared here, where this side's x and this side's x, then if I have an x, so this is x squared, this is x times 1, which is just x. So if I have 3 x's and then 3 more x's, what I have is x squared plus 6x. So let me write that down. So this gives me x squared plus 6x. So what completing the square says is I can take this term here and divide it by 2, 6 over 2, and square it and have a perfect square trinomial. So this would be x squared plus 6x plus 6 over 2 is 3, and 3 squared is 9. So it's saying this would be completing the square. So let's see if that's true. So I'm going to take this and divide it in half and put half of the x's down here and half the x's here. So now I have x squared, I have 3x below, 3x here, and now what it's saying is to complete the square, I have to add 9. And look at that. I have 9 unit squares. Each one of these is 1. So adding them all up, that's plus 9. So that's completing the square. So that's what we'll be doing, but using math rather than algebra tiles. So what value of c completes the square? So c would then be 12 divided by 2 squared. So 12 divided by 2 is 6, and so you have 6 squared. So c would be 36. Now if we look at this c, we have 8 divided by 2 squared, which is 4 squared, and that's just 16. So that's how we complete the square. So if we wrote this x squared plus 12x plus 36, that square would be completed. So that would factor as x plus 6 squared. So each side of the square, the new composite square, would be x plus 6. Just like this composite square was x, whoops, it got a little disorganized there in the move. But we can see that we have the sides x plus 3 and x plus 3, or x plus 3 and x plus 3. All right, so this one would be x squared plus 8x plus 16. So its perfect squared factor is x plus 4 squared. So what are the solutions of each quadratic equation? So we want to complete this square here. So we're going to do x squared plus 10x, and then we're going to add 10 over 2 squared minus 9. But we can't just add that. We're going to have to, we are going to have to subtract that or add that to the other side as well. So 10 over 2 squared. So what this gets us is x squared plus 10x plus 5 squared, and that's minus 9 equals, and then this is also 5 squared. Let's move this 9 over here now. And we have x squared plus 10x plus 25 then equals 25 plus 9. All right, so we know that this is x plus the square root of 25, which is 5 squared. And then this equals 25 plus 9 equals 34. Let me make a little room here. Now, if we take the square root of this and we do a plus or minus and we put a square root of it here, we can take this x plus 5 out of the square root house, so it's just x plus 5. Because we know that the square root of a squared is plus or minus a. So that's where this plus or minus comes in. So we have equals plus or minus 34. So now all we have to do is get x by itself. So we use an additive inverse of minus 5 here and minus 5 here. So our answer then is x equals negative 5 plus or minus 34. So that gives us two solutions. So we should be aware that that is two solutions, not just one. So we would write it like this. Negative 5 minus the square root of 34 and negative 5 plus the square root of 34. So those would be our two solutions. All right, so let's try this one. We're going to do x squared minus 8x. We want to add 8 divided by 2 squared here. And we have a minus 6. And then on the other side of the equal bar, we're going to add 8 over 2 squared. So this gives us x squared minus 8x. And then this is 8 divided by 2 is 4. 4 squared, 16. Minus 6 equals 16. Okay, let's move the 6 over here. And this is a perfect square trinomial right here. So we are going to write x minus, and the square root of 16 is 4. And it's a minus sign because of this, and that's always a plus for a perfect square trinomial. So that's 0 there, and then we have 16 plus 6 is 22. So we are going, let me make a little room here for our square root. So we're going to do a square root here. We add a plus or minus, write another square root here. So this gets us x minus 4 equals plus or minus the square root of 22. We use an additive inverse here. Let me just divide this so you guys aren't confused. And we're going to add 4 here. Then we have x equals 4 plus or minus the square root of 22. So what the solution set would look like is 4 minus the square root of 22 and 4 plus the square root of 22. And there you have it. All right. So you may feel like you're walking through a maze sometimes in my math class, but now we're actually going to talk about walking through a maze in the math class. All right, so we have a maze and a walkway with the same total area of the example in the book. So we have 5,616 square yards, and the walkway is now 1 yard wide. So it's 1 yard wide all the way around. Now the length of the maze, though this does not look like it's twice this, the length is twice the width. So if we want to solve this equation, we have for this side, from here to here, this would be the 2x plus this 1 plus this other one. So we have 2x plus 2 is 1 plus 1 is 2. And then this side here and here would just be the x. And then we have this 1 here and 1 here, so plus 2. So we can create the square 2x plus 2 and x plus 2 times x plus 2. So we have the length times the width of the maze plus the walkway around the maze. And then that is going to equal 5,600 or 5,616 yards squared. Right, so we're going to use FOIL. So we have 2x squared plus 4x plus 2x and then plus 4. And that's going to equal 5,616. And that's yards squared. So let's just remember yards squared at the end. Okay, so we are going to combine everything. Let's move this 4 over here. And we get 2x squared plus 6x, and that's 0. And then that just equals 5,612. All right, if we notice there's a common factor throughout all this, and that is 2. So we're going to divide everything by 2. And we get x squared. Can we do that? That's x squared plus 3x equals, and this becomes 2806. All right, so we want to add right here, complete the square. So we're going to put 3 over 2 squared, and then we're going to add 3 over 2 squared. All right. So this gives us, we have x plus 3 over 2, and that's squared because this is now a perfect square trinomial. And this equals, well, 3/2 squared, that's 1.5 squared. So 1.5 times 1.5 gives us 25 there. We have 7, then 15. So that gives us 225 with the decimal there. So we are going to add 2 and 25.25 here. So we have 2808.25. All right, let's make a little more room for us. So now what we're going to do is do a square root. Let's move this over. So we're going to do a square root around this so we can start solving it. We'll put a plus or minus here and do a square root here. So we get x plus 3/2 equals, and the square root of this is about, we're going to approximate this, and we aren't going to have a negative length, by the way, so we don't really need that minus there. It's just going to be a plus. So this approximates to about 53 when we take the square root of 2808.25. It's very close. It's 52.99. So let's approximate it to 53. So this is 1.5. So we're going to subtract 1.5 from this side and subtract 1.5 from this side. So we get x, let's write it over here, x equals, and that's going to be 51.5 yards. So x was our width. So this is our width. The length was twice that. So then the length, which was 2x, will be 103 yards. So that's the length. All right, let's go to the next example. All right, so what is the vertex form of the function? So let's remember what vertex form is. It's f of x equals a times x minus h squared plus k. So that's what we're looking for, the vertex form. All right, so we don't have to do it exactly like the book. They're moving this 3 to the other side. You don't need to do that. So let's see how we can do it a little more simply. So we have x squared minus 2x. We're going to add the perfect square term, which is 2 divided by 2 squared, and we can't just do that. So we're going to subtract it as well. And then we're going to add 3. So basically, when I add this and subtract that, I'm not affecting my equation at all. But I am creating a perfect square trinomial right here. Make this bracket so it looks better. So that's my perfect square trinomial. So now I can write vertex form in just one more line. So I know 2 divided by 2 is 1, and I have a minus sign here. So this is going to factor as x minus 1 squared, since this is a negative 1, and then that's plus 3, because 1 squared is just 1, but that minus sign is outside the square, so it doesn't go away. So then our vertex form is just going to be at x minus 1 squared, negative 1 plus 3 is 2. And just so you know, the vertex happens to be, that would be 1, 2, just so you stay in practice, because this has to be a negative sign, and that's a positive for positive values of the vertex. All right, so let's do this one. So we have y equals x squared. We have plus 6x. We have plus 6 over 2. We're going to square it, and then we're going to subtract it. So we're not affecting the equation at all. So these zero each other out, but now we've completed our square right here. So we have y equals 6 over 2 is 3. So 3 squared. So we have our perfect square trinomial is x squared plus 6x plus 3 squared, which is 9. And then this is 3 squared. So that's 9 plus 25. So now we have y equals, this factors as x plus, and then the square root of 9, which is 3. And then 25 minus 9 is just plus 16. So there we have it, the vertex form of this equation. And this is the vertex form of this equation. All right, so our vertex for this one would then be -3, 16, because that would have been an x minus -3 in here squared plus 16. Okay, so that's where that -3 comes from. All right, let's find the minimum value of this function. So we, again, are not going to do it the way the book's example is, because you don't need to move this to the other side and then move it back. Okay, as long as you understand what you're adding and subtracting. So first we have 7x squared plus 168x, and then we're going to add 105 here. Okay, so both of these has a factor of 7, so I'm going to take that out. So I have 7 here, I have x squared plus, and there are 2 7s in 16 with 2 left over, and 4 7s in 28. And then I'm going to have to add something here. Now, if I'm adding something here, I'm going to have to subtract something here, and I'm also multiplying by 7. So I have that same something right here, and then I have plus 105. So this something that I'm going to be adding is going to be 24 divided by 2 squared. So I'm going to write here 24 divided by 2 squared. Okay. So let's look at what we've got here for our vertex form here. So we have 7, we have x squared plus 24x. 24 divided by 2 is 12. 12 squared is 144 minus, and then this is going to be 12 squared again, so 7 times 144, and then plus 105. Okay, if you're confused why I did this again, this is going to be 7 times 144 that's added into the equation. So I have to subtract 7 times 144 here. So I'm not doing anything to the equation. So I'm basically adding nothing. I'm just rearranging some numbers. So now I have y equals 7. And this is going to be x plus 12 squared. Now we have to figure out, well, what is 7 times 144? So 7 times 144 is, we have 28, 30, 108, 1,008. So we have minus 1,008 and plus 105. So we have y equals, we have 7, we have x plus 12 squared, and then we have 1,000 minus 105, and we're going to remember it's going to be a negative because that's farther from 0. So we have 0, 3, and then this is going to be 9, so 903. So what this means is we have a parabola that's opening up like this, and it has a vertex right here at -12 and -903. So its minimum value of the y or minimum value or height height is always the y, not the x. So the minimum value then is negative 903. Okay, so that's also our vertex here. All right, that's it for this lesson. Have a wonderful day. Bye-bye.